So today we're going to start looking at these things called polynomials, which I'll talk about in just a little bit. But here at the beginning, I just want you to try the warm-up. It's just distributing and simplifying the expression. So remember that your answer is going to look very much like another problem at the end of it. So go ahead, try these on your own, and when you're finished, we'll go over them. So now that you've had a chance to look at them, we're going to talk about how you would solve them and go over the answer. So in the first problem, the first thing you would do is you would distribute that 4 to each piece in the parenthesis. So you'd have 5, whoop, my x didn't show up, 5x plus 8x plus 28. My like terms are my x's, so the 5x plus 8x gives me 13x plus 28. And that becomes my final answer because I've simplified it as much as I possibly can. Looking at this next one, please make sure you remember to change subtraction to plus the opposite. And again, we're going to go ahead and distribute through the parentheses. So 9x plus negative 6x plus negative 12 plus 3. Combining my like terms again, my x's go together and I get 3x. My negative 12 and my 3 go together, and I get negative 9 as my constants. So again, we're going to begin looking at these things known as polynomials, and we're actually just going to start by adding and subtracting them. We're going to go back to the basics. But before we actually get into adding and subtracting, we need to talk about what these things are. We have this thing known as a monomial. A monomial is just one little piece of the problem. Okay, and that one little piece can either be a number by itself, a variable by itself, or a number and variable, that happen to be multiplied together. The biggest thing is that it has to have whole number exponents. Okay, so we can't have fraction exponents, we can't have negative exponents. They need to be positive whole number exponents. We also have this thing known as a degree. The degree is how we classify the polynomials. And in order to get the degree, it is the sum of the exponents of the monomials. And then if we have lots of monomials together, the degree of all of those monomials is whichever piece has the highest degree. So you would find the degree of each piece, and the highest one we would say is the degree of the entire polynomial or the entire group. So looking at this chart here, all we're looking at is this a monomial, yes or no? Okay, and then what would its degree be? So this first one, this 10, is a monomial. It is a monomial because it is by itself. It's just a number by itself. And it actually has degree 0 because it's the sum of the exponents with variables. And since we don't have any variables, let alone variables with exponents, it has a degree of 0. 3x has a degree of 1 because technically there is a hidden 1 above the x. Now this 1/2 ab squared, that a has an exponent of 1. The b has an exponent of 2, so our final degree is actually 3. Okay, it's the exponents of both variables being added together. And the last one has degree 5. So here, this first one is no, it is not a monomial. And the reason it's not a monomial is we can't add. Sorry, my writing's horrible today. We can't add. A monomial has to be a number by itself, a variable by itself, or the product or multiplication of a number and a variable. Number 2 is also no, and you can't have a variable in the bottom of the fraction. Okay, so we can't have the variable in the denominator. And the reason being, if I were to rewrite this, this would be 2n to the negative first. And if you remember, we can't have those negative exponents. 4 to the a is also a no. It is not a monomial. We can't have variable exponents. And the reason we can't have variable exponents is that variable could stand for anything. So it could in fact be a fraction exponent or a negative exponent, and we wouldn't be able to tell, we wouldn't know. So therefore we get rid of all variable exponents. And this last one, x to the negative 1, obviously that is a no as well, because we know already that we can't have the negative exponents. So all we're looking at here is we're going to take this is known as a polynomial. This polynomial is made of 3 monomial pieces, the 15x, the negative 1x cubed, and the 3. Okay, so addition signs hook all of the monomial pieces together. We want to write it in order so that our exponents decrease from left to right. So we want the highest exponent first, so it's negative 1x to the third. The 15x comes next because it has an exponent of 1, and the 3 goes at the end because it does not have an exponent. In order to identify the degree, we have to identify the degree of each piece. So this first piece has degree 3, because there are 3 x's. My second piece has degree 1. My last piece has degree 0. The degree of the entire polynomial is the highest of those pieces, which is 3. Coefficient, we know that coefficient means number in front of the variable. Leading typically means first, so we want the first number that is in front of a variable. In this case, it would be negative 1. Go ahead, try this one on your own. It's the exact same thing, we're just decreasing from left to right. So once we decrease it from left to right, we're going to have negative 4b to the fourth plus 3b cubed plus b squared. This first piece has a degree 4, the second piece has degree 3, and the last piece has degree 2. So the degree of the entire thing is 4, and my leading coefficient is negative 4. So we want to determine if this thing is a polynomial. And a polynomial is just made up of monomial pieces. If it is, we need to identify its degree and what type of polynomial it is. This first one, yes, it is a polynomial. Okay? It's a polynomial with the classification of monomial. I don't think I spelled that right. Monomial. I got one too many O's. It is a monomial and it has degree 0. Monomial means one piece. So looking at B, this is yes, it is a polynomial. This time it's a trinomial. Tri meaning 3. So it's a 3-piece polynomial, and it's going to have degree 2 because the highest of the degree pieces is 2, so the entire thing is 2. This last one is no because we have the variable exponent. If it was a polynomial, we would call it a binomial because there are 2 pieces. Go ahead, try these 4, same thing. Is it a polynomial, yes or no? If it is, please name it and tell its degree. First one is no. Obviously, we cannot have those negative exponents. Number 3. Yes, it is a polynomial. It is a binomial because there are 2 pieces. This first piece has a degree 4. The second piece has a degree 5. So it's the degree of 5 for the entire polynomial. Number 4 here, this is yes. It is a monomial. and it has degree 3. Last one, no, we can't have variables in the denominator. So at this point, this is the end of the first day lesson on adding and subtracting. This was just kind of classifying, getting some of the vocabulary down. You should have a worksheet in front of you. If you don't, you should be able to find it off of the team calendar and or the website. And tomorrow we're going to look at how to add and subtract. So now that we're on day 2, we have our traditional warm-up. Go ahead, work on the warm-up, and when you're finished, we will take a few minutes and go over it. So in number 1, yes, it is a monomial. It is a trinomial. And it is of degree 2. Number 2 is yes. It is also a trinomial. And degree 4. 4 is yes. It is a binomial. And it is degree 1. And number 3 is no. Why? Because we can't have those negative exponents. So in order to add, it's just like you added in elementary school where we lined up place value. Here we're going to line up our like terms. Okay, so instead of lining up based on the ones and the tens and the hundreds place, we're going to line up based on like terms. Like always, you do want to change your subtraction to plus the opposite. Because it is addition, it does not matter which polynomial goes on the top of your addition problem, but traditionally, usually the first one goes on the top, the second one goes on the bottom. So I have 2x cubed plus 5x squared plus 1x. My 2x cubed in the second problem is going to go under my 5x squared. I'm sorry, that's 2x squared. My x cubed will come out in front. And the 1 has no like term, so it kind of goes off by itself. Do not put it under the 1x. Either leave a space, or if you have to, you can actually fill in the spaces with zeros. Now we're going to add. When we add, we are only adding coefficients. The variable just comes down. So 1 plus 1x plus 7x squared. That should be a negative 5x, so that's not a 7. That'll be a negative 3x squared. And then the 2 and the 1 will give me 3x cubed. Looking at another one together, again, I'm going to change my subtraction to plus the opposite. So I have the 3x squared plus 1x plus negative 6. And I have the 1x squared plus 4x plus 10. Going ahead and adding. Because we're not doing any borrowing or carrying, it does not matter if you add from the left to the right or the right to the left. In elementary school, you're always taught to start on the right. Oh, excuse me. Because of carrying, so that's how I traditionally start. But by no means do you have to. So here is 6 for you to practice. Again, you're just lining up your like terms. When you're finished, because of spacing in room on here, I'm just going to write down the answers. But if you have any questions on how I got any of those answers, please feel free to either send me an email, come in and visit at any time. I'm more than happy to help clear those up. So now that you've had a chance to try them, the first one is 10k squared plus negative 9k plus negative 14. Please remember, if you happen to switch your k's to x's, it's no big deal. You can pick any variable you want. Number 2 is 1x squared plus 3x plus negative 12. we also have 5x cubed plus negative 1x squared plus 1x plus negative 4. Number 4, 1m squared plus, 1m squared plus 9m plus 9. Number 5 is 6h squared plus negative 4h plus negative 2. And number 6 would be 13a squared plus negative 4. So again, now that we're at the end of addition, please go ahead and try the worksheet. If you have any questions, as always, please feel free to let me know. So now we are on day 3. Today we're going to look at subtracting, but before that, let's go ahead and review our addition. Remember to line up your like terms. So in the first problem, if my stylist will work this morning, we get 3d cubed plus 3d squared plus 11d plus negative 2. For number 2, 1p cubed plus 6p squared plus negative 11p plus 7. And the last one, negative 2x cubed plus negative 4x squared plus 8x plus 1. So with subtraction, just like always, we're going to change all of our subtraction to plus the opposite. And you'll notice when we do that, and we learned by distributing, that that's actually going to go to a plus negative 1 there. Which means everything in the second parenthesis must be multiplied through by a negative 1. So we're going to have the 4n squared plus 5. I separated because I know I'm going to have a little bit of a gap there. Instead of negative 2n squared, that is now going to become positive 2n squared. I'm going to have negative 2n in the middle, and I'm going to have positive 4 at the end. Place a 0 in the middle if you need to. So I'm going to end up with 6n squared plus negative 2n plus 9. So the only difference again with subtraction, between subtraction and addition of polynomials, is that you do have to distribute a negative 1 through the second parenthesis. Once you distribute through that negative 1, then it literally is just like addition. So I have 4x squared plus negative 3x plus 5. My second polynomial, as I distribute through the negative 1, will be x squared plus positive 1x plus positive 8. Final answer will be 1x squared plus negative 2x plus positive 13. Go ahead and try these 6 on your own. Again, for the sake of time, I'm just going to go ahead and go down over the answers. And if you have any individual questions on any of these, I'll be more than happy to answer them. So now that you've had a chance to try them, the first one is 6c squared plus 14